Hello there. Thank you for taking the time to tune in to this Global Environmental Agency broadcast. In this video, we will brief you on the GEA's efforts to combat our planet Earth's climate crisis. Our planet has gone through immense changes in the last 50 years. The ice caps have fully melted, water levels have risen 20 feet since the year 2000, hurricanes are more frequent and powerful, and uncontrollable wildfires continue to burn up ecosystems. There is no longer a frost season, soil moisture is at an all time low, and droughts and heat waves plague our cities and towns. Every year yields fewer and fewer crops and unhealthy livestock, leading to an oversaturation of the synthetic food market and an increasingly hungry population. If our planet continues on this downward trajectory, our Earth will be fully uninhabitable by 2060, only 10 years from now. While efforts are being made to colonize other planets in our solar system and beyond, we do not have the infrastructure to accommodate the mass migration of our entire population. Therefore, we have made strides to address the problem of climate change as it is on our planet Earth. Before the grand unveiling, let us first set the stage for our design problem and solution. As previously mentioned, and as you all have experienced, the effects of climate change in recent years have been rampant. The GEA was established 20 years ago at the 2030 United Nations Framework Convention on Climate Change. One of our main goals has been to establish standards for energy loads produced by each country. While we have held countries and their citizens accountable for joining our coordinated effort to lower our global carbon footprint, these efforts simply have not been enough to reverse the effects of global warming. The following map represents the average yearly temperature from the year 2000, 2025, and finally 2050. The data makes it clear that our efforts have simply not been drastic enough. We need a total climate overhaul as soon as possible. Our team of top scientists, engineers, architects, and meteorologists have been working tirelessly to develop a permanent solution through countless hours of meticulous research and journaling. On January 17, 2048, our database of literature and references provided a source of inspiration that held the answers we were looking for and set the stage for our research. This source was an old architectural text, The Architecture of the Well-Tempered Environment by Rainer Benham. Our team discussed how we could use architecture to temper our ever-worsening environment, and we found that some inspiration lay in a certain chapter, Towards Full Control. As we read Benham's account of the history of air conditioning, from an industrial to a residential scale, we understood what had to be done. We needed to take technology that we already had, but apply it on a larger scale. While we had been so focused on creating rules to limit the use of air conditioning on a residential scale to cut down on energy consumption, we never considered air conditioning to be a solution to our problem. Without further ado, we are pleased to present to you our solution to the global climate crisis, the CAC 2000XL, or the Climate Conditioner. Over the course of 5 years, and with a budget of 15 trillion American dollars, our agency will be overseeing the production and installation of these climate conditioners around the globe. The organization will be based on a grid system, with each unit covering a climatic radius. While the technological components are similar, these machines are more than just the big brother to your household air conditioning unit. They will be placed in cities to help with smog control and air filtration. This will vastly improve city life and allow for citizens to spend more time outdoors in the various metro parks. You will also find them in mountain ranges to revive snow accumulation and glacial production to account for the immense loss of glacial formations in the northern and southern poles of our planet. You can now break those 20-year-old skis out of the closet. Offshore units placed at sea will play a huge role in alleviating the damage caused by hurricanes every year. These units will create miniature storm systems that will be used to intercept and divert larger storms that are bound for coastal areas. These are merely a few examples of many applications of our climate conditioners to make our planet a better place. So how do these climate conditioners operate? At the very core, these machines work in the same manner as any other air conditioner. A fan system pulls hot air from a condenser to the outside. The condenser, or heat exchanger, is the coil system that deals with the hot refrigerant. The first expansion valve restricts refrigerant flow. By reducing the pressure of the refrigerant, the temperature changes from hot to cold. The evaporator is the coil system that handles the cold refrigerant. The blower pulls room temperature air over the cold coil and disperses the temperate air. During this process, the refrigerant turns from a liquid to a vapor. The compressor and the second expansion valve work to raise the pressure of the refrigerant from low to high. As the high pressure vapor cycles through the compressor, The refrigerant becomes a liquid, as it was at the beginning of the cycle. What sets this unit apart is the scale of its components and cycle. It runs on a quadruple refrigeration process to accommodate the massive load required of it. While this explains how it controls temperature, how does it handle vapor distribution and air filtration? These machines rely on the method of cloud seeding to control weather in their zones. Instruments on the roof provide meteorological readings and inform the machine output load at any given time. A mixture of calcium chloride and water is created from the fluid cistern. This fluid is pumped up to the refrigeration tier by way of three 1,000 liter per second capacity pumps. These pumps and other operations are powered by three industrial-grade electric engines. When the mixture is fully prepped, it is dispersed out of the pressure vapor nozzles at a rate that sends the particles into the local atmosphere. These particles accelerate cloud condensation. The output cooling temperature of the unit can control whether this condensation is in the form of rain or snow. And how does this machine clean air? A collection vent pulls dirty air into a Calvin cycle coil. This coil turns dirty carbon into energy by converting it into glyceraldehyde 3-phosphate. Supplemental energy from the grid will allow for the transformation to 3-phosphoglyceric acid, which can then be converted to ribulose bisphosphate. This process will be used to power the operations of the machine as it continues to filter and distribute clean air. Oxygen output fans will distribute the clean air for us to breathe. And how do these machines stay running? We rely on a duo comprised of an engineer and a meteorologist to man each station. This job requires that each team study weather charts, complete routine checks of components, facilitate any maintenance, and oversee daily operations. The housing accommodations include a personal cabin and bathroom for both team members, as well as a kitchen and dining tier, and a control and workroom. A walk-in fridge and ample storage allows for up to a year of unassisted living, as it is imperative that operators have all needs met in remote areas that are not easily accessible. We thank you for listening to our video, and hope you are as excited by this prospect of climate conditioning as we are. In as early as 5 years, we can expect to regain an adequate quality of living on a global scale. If you are interested in joining our team or applying to be stationed at a unit, please head to our website at gea.gov.